Welcome to Fast Math Solutions on Maths with EJD. In this video, I want to show you the proof that for y equals e raised to power x, y is the same thing as y prime, is the same thing as y prime prime, is the same thing as y prime prime prime, the same thing as any level, any order of derivative will keep giving you the same e raised to power x. So it's more like that's a cat with infinite lives that will never die. So that's the whole thing here. So as you keep differentiating e raised to power x, you keep getting e raised to power x forever and ever. So that's what this proof is about. So let's go for it. Okay, so the idea we will have to apply here is the idea of Maclaurin series. So the Maclaurin series expansion of y equals e raised to power x is given as this, you know. So y equals e raised to power x is the same thing as 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x raised to power 4 over 4 factorial plus x raised to power 5 over 5 factorial plus x raised to power 6 over 6 factorial plus x raised to power 7 over 7 factorial and so on and so forth, right? Now let's look at the first derivative, that's y prime. See, y prime is dy dx. So it means you just differentiate term by term. So differentiate 1, that is 0, something like 0 here. Differentiate x, you get 1. I mean, if you differentiate 1, that goes away as 0. And then you have differentiate x, you get 1. Differentiate x squared over 2 factorial, that is 2x. 2 factorial is the same thing as 2 times 1. All right. Then differentiate x cubed. What do you get? You get 3x squared over 3 times 2 factorial. Differentiate x raised to power 4 over 4 factorial. That's 4x cubed over 4 times 3 factorial. I'm actually breaking the factorials down because since you have 4 here, we are looking forward to it canceling out. So that's why I'm doing that. Then differentiate x raised to power 5 over 5 factorial. You have 5x raised to power 4 all over 5 times 4 factorial. Same here, 6x x raised to power 6 over 6 factorial. That's 6x raised to power 5 over 6 times 5 factorial. Then x raised to power 7 over 7 factorial. That's 7x raised to power 6 over 7 times 6 factorial. So having done that, then you can tidy things up like I always like to say. So 2 cancels 2, 3 cancels 3, 4 cancels 4, 5 cancels 5, 6 cancels 6, 7 cancels 7. And you end up getting 1 plus x. You end up getting exactly what you started with. Okay? So you see that the first derivative is like that. It has given birth to the same e raised to power x, right? So then let's look at the second derivative. As expected, right? It's the same thing. Differentiate 1, that's 0. Differentiate x, that's 1. Differentiate x squared, same thing like before. Same thing, exactly the same thing like before. And then when you tidy things up, you end up getting exactly the same 1 plus x, all that, which is still the same thing as the e raised to power x we started out with. So do it as many times as you like. It's exactly the same. The third derivative differentiates 1, it goes to 0. X comes to 1. Then differentiate x squared, you get this 2x over 2 times 1, and so on and so forth. And then you tidy up again, and all of that will just go again. And then you're back at the same e raised to power x. And mind you, this is the third derivative. So if you do fourth derivative, fifth derivative, sixth derivative, seventh, eighth, ninth, 1 million derivative, right? You get the same thing. So that's why we can just come and generalize it. That for y equals, so for y equals e raised to power x, for y equals e raised to power x, all right? You end up getting the nth derivative. I mean, any kind of derivative you do. If one prime is when n is 1, prime is when n is 2, and so on and so forth. You end up getting the same expression. And that is why the derivative of y equals e raised to power x is always the same e raised to power x, whether no matter the order of the derivative. Okay, for this kind of interesting videos, make sure you sign up to my channel, click on the notification bell so you can get alerted whenever a new video is released. Thank you for listening. See you in the next video.